70-740, Lesson 17, Implementing Network Load Balancing. That's our acronym NLB. What is network load balancing? Well, that's what we're going to talk about today. We're going to be looking at how we go about configuring network load balancing, those port rules, what we call filtering mode, affinity, our cluster operation mode. We've got some new topics here. This is not the longest lesson in the course, but it's going to be a little bit longer than our lessons that we've just had in the past couple. But let's begin by talking about what network load balancing is, NLB. Network load balancing transparently distributes traffic across multiple servers by using virtual IP addresses and a shared name. With NLB, you gain fault tolerance and enhanced performance. It's often used with mission-critical web servers, but it can be found with other types of servers. Now, if we're going to have a cluster, we've got to have at least two servers, right? And as we've talked about in our previous lessons, each one of those servers is called a node. Each one of those nodes has to run the service application or the role or feature that we want to make available in that cluster. Could be a web server. In the example they give in the lesson, an FTP server, or hopefully they're not running FTP. Come on now. That's transmitted in clear text. We don't want to do that, right? SSH, which is secure shell. It could be a remote desktop server. It's a scalable, high availability feature that we find in Windows Server 2016. What does the term scalable mean? It means you can add more servers as demand increases. We can scale with the need. You can have from 2 nodes up to 32 nodes. So this is very, very flexible. It's very scalable. When we create that cluster, we're going to create a virtual network address and an adapter that is assigned to the entire cluster. New network requests are sent to that virtual network address, and then they get distributed across the nodes that are participating in our NLB cluster. Now, we can configure that cluster to even out the requests, or we could give one node preference over another node. There's a lot of flexibility in the way we can set this up. Keep in mind, though, that all hosts in the NLB cluster receive the incoming traffic. However, only one node in the cluster accepts the traffic, and the other nodes drop the traffic. That node that accepts the traffic is determined by the configuration of our port rules and our affinity settings, and we're going to talk about those two topics in greater detail later in the lesson. Now, if a node fails, that node obviously will no longer be able to accept requests. It's failed, right? However, no service is lost because the other nodes are available to accept the request. If when that node comes back online, it starts accepting requests and the traffic is distributed among the other nodes however the rules dictate. NLB can detect the failure of cluster nodes by the use of what we call heartbeats. There's packets being sent out. They're transmitted every second between the nodes in the cluster. If one of our nodes or our servers misses 5 consecutive heartbeats, that's in 5 seconds, that node is automatically removed from the NLB cluster. Now, once we add a node or we remove a node from a cluster, this is what we call convergence. This is when convergence occurs. This is where the cluster determines its current configuration by building a membership of nodes and mapping those client requests based on the available nodes. Now, convergence can only occur if each node has the same port rules. What are our prerequisites for NLB? Well, keep in mind that to support NLB, all hosts in that cluster must reside on the same subnet. We can't do this across subnets. Within that cluster, all the network adapters have to either be multicast or unicast, one or the other. It's not going to work to have some nodes doing multicast and other doing unicast. You need to configure them the same. And here again, we're going to talk about multicast and unicast later in this lesson. If you are going to use unicast, the network adapter that's used to handle that client to cluster traffic must support changing its MAC address. And then finally, the IP addresses assigned to the nodes have to be static. If these are servers, they should have static IP addresses anyhow, right? It's just that simple. Now, you can span multiple geographic areas with your hosts, but to achieve your convergence successfully, you've got to have fairly low latency. It can't exceed 250 milliseconds. If all your nodes are local to the same switch, it's going to be much lower than that. However, if you're spanning across multiple geographic areas, it could easily exceed 250 milliseconds. So you need to take a look at that. If you do need to geographically disperse those NLB clusters, you should deploy a cluster at each site and then use what we call DNS round robin. By using DNS round robin, our DNS can distribute traffic between those sites. Now, before we can configure a node, we have to install network load balancing. But just like failover clustering, NLB is a feature, it's not a role. We use it to enhance other roles like our web server. Once you've installed NLB on each one of your machines, you then create the node and add each node to the cluster. Now, we're going to use Server Manager to add the NLB feature. Once it's installed, you can then use the Network Load Balancing Manager to configure the cluster. And just the same way as in our lessons with failover clustering, you're going to need to install that network load balancing on each server / node that's going to be part of that cluster. Now, here is those steps to go ahead and install that. Take note, if failover clustering feature was installed, it's got to be removed. You can't have both. It's got to be one or the other. But it's just as simple as going in to add roles and features and click next, 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 next. That's 4 next. That gets you to the feature selection page. And then you select network and load balancing, click next, and on through just like we do everything else. You can do it from PowerShell using the add-Windows feature and then NLB, RSAT-NLB. What's that RSAT? That's your remote server administration tools. To configure it, you need to configure host parameters, cluster parameters, and port rules. What do they do? Well, host parameters defines what each node can do. Cluster parameters, just as it sounds, configures the cluster as a whole. Those port rules control which ports that cluster services and how those requests are balanced across the servers. Here are those steps for configuring your NLB cluster. Now, we're going to be running through this in our lab, so I'm not going to explain this. We'll just scroll on down through all the different steps here because, like I said, this is going to be covered in our lab, so you can get the in-depth knowledge in the lab. Now, if you want to add additional hosts, you simply right-click the cluster and choose Add Host to Cluster. It's that simple. You select the interface for the cluster, you configure what's called the unique priority, and you define any port rules. Once that host is added, convergence will automatically occur. And then, once it's completed, you'll see the status showing as converged. Now, we can do this using PowerShell. Just like everything else, there's many PowerShell commandlets. And I'm not going to try to read each one of these to you. That's up to you. You can go through that. Now, you do need to configure port rules. Understand that these options are similar to the configuration you're going to perform when you first create the cluster. With port rules, you can configure how requests to specific IP addresses and ports are directed by your cluster. We can load balance web traffic using port 80 across all nodes in an NLB cluster, while we could redirect all requests for a remote desktop using TCP port 3389 to a specific host. When you're setting up those port rules, you're going to configure the virtual IP address that the rule is going to apply to, the TCP or UDP port range that the rule should apply to, the protocols that the rule should apply to, and also what's called the filtering mode that specifies how the cluster handles traffic. Now, we're going to talk about filtering mode here in just a second. But here are those steps for configuring your port rules. Okay, configuring filtering mode and affinity. Remember at the very beginning we talked about that? We said we'd discuss it farther down the lesson. Well, here we are. Affinity determines how the servers are going to balance the load. When you configure port rules, you first select the filter mode. The filter mode specifies which hosts can respond to those requests. You can select multiple host, single host, or disable. Obviously, multiple host permits all cluster hosts to actively respond to the client requests. If you select single host, well, it allows only one cluster host in the cluster to actively respond to those client requests. Now, they can have priority. So if that particular host fails, the host with the next highest priority will take over for that failed host. Disable is obviously it prevents the cluster from responding to that type of traffic. If you do choose multiple host filter mode, then you have the option to configure the affinity. The options for affinity are none, single, or class C. None means any cluster in the node responds to any client request. Single means a single cluster node handles all the requests from a single client. Class C means a single node responds to all requests from a Class C network. This is often found when used with multiple proxy servers. Each node in a cluster must have identical port rules. The only exception is the load weight when in multiple hosts filter mode and handling priority in a single host filter mode. If those port rules are not identical, the cluster is not going to converge. If you wish to modify the port rules for an individual host, you simply right-click the host in the left-hand pane and choose Host Properties. You then select Port Rules and click Edit. This is what that Add Edit Port Rule dialog box appears as. What is cluster operation mode? When a host communicates with another host, the host uses unicast or multicast packets. When communicating using unicast, each packet is sent to a single network destination identified by a unique address. In other words, a host sends packets to a single computer. With multicast, those packets are sent to multiple computers simultaneously in a single transmission from the source. In other words, one to many. That's multicast, right? Copies are automatically created on routers when the packet needs to go to different subnets. If you have 5 hosts on the same subnet and 2 hosts on another subnet, One set of packets is sent from the source host. When packets get to a router where the packets need to go to two different pathways, the packets are copied and sent to the two separate subnets. When the first set of packets gets sent to the subnet with 5 hosts, only one set of packets gets sent to all 5 hosts. The second set of packets gets sent to the subnet with 2 hosts, and only one set of packets gets sent to the 2 hosts. Now, if you configure an NLB cluster to use unicast mode, NLB will replace that network card's original MAC address, and all cluster hosts will use the same unicast MAC address. When you use unicast mode with a single network adapter on each node, the computer can communicate only with the other computers within the same subnet. Understand all these different points. For example, if you perform management tasks on the computer, you're going to need to perform these tasks on a computer that's on the same TCP/IP subnet as the node. Or you need to have a second network adapter and address that you can use. Now, lastly, if you use unicast mode, you can use separate virtual LANs, VLANs, for cluster traffic and management traffic. Now, when we use multicast mode, when an NLB host is in multicast mode, each network adapter has 2 MAC addresses, the original MAC address and the virtual MAC address. However, when you're using that multicast mode, some routers might see a unicast IP address with a multicast MAC address as an invalid packet and reject that update to the ARP table. So if this happens, you as the network administrator might need to manually add ARP entries to the router. Another mode that's available is IGMP multicast mode, Internet Group Management Protocol multicast mode. It's a special form of multicast mode that prevents the network switch from flooding with traffic. When you use that IGMP multicast mode, traffic is forwarded only through the switch ports that are part of the NLB cluster. Please note, though, that to use IGMP multicast mode, you need switch hardware that does support IGMP multicast mode. If you want to modify that cluster operation mode, you're going to right-click the cluster in the Network Load Balancing Manager and choose Cluster Properties. And then on the Parameters tab, you modify the IP address, the subnet mask, the full internet name, and the cluster operation mode. How do we control hosts in a network load balancing cluster? Well, you as the administrator have the ability to manually add or remove nodes from a NLB cluster by using the Network Load Balancing Manager. You can also suspend or resume a cluster node and perform a drain stop. Before you remove a node, you want to perform a stop or a drain stop action. Stop action terminates all existing connections to the cluster node and stops the NLB service. The drain stop action blocks all new connections without terminating the existing sessions. So what this means is to perform maintenance on an NLB node, it needs to be temporarily removed from that cluster. So what you want to do is you want to select drain stop. And in this way, new connections aren't going to be accepted and the current connections won't be prematurely stopped before their requests get completed. To control the host, you right-click the host, you choose Control Host, and then you select the appropriate action as you can see on the screen. Remember, the stop action immediately terminates all connections to that host. Drain stop will block new connections and allow the current connections to be completed. How do we go about upgrading an NLB cluster? Well, if you're running Windows Server 2012 or 2012 R2, there's two ways to upgrade that cluster to Windows Server 2016. You can upgrade all the hosts at one time, or upgrade each host one at a time. The quickest upgrade path is to take the entire cluster offline and perform a rolling upgrade. Now, if you do this, of course, the cluster is not available. If your cluster requires no downtime, and this may be the case, you can upgrade each individual cluster host one at a time. If you're going to do this, as you upgrade each host, you should first perform a drain stop and let that host block any incoming new connections, service those current requests, let them complete, and then you can go about performing that upgrade. In this lesson, we learned that high availability is a system design protocol and associated implementation that ensures a certain degree of operational continuity during a given measurement period. This is how we define high availability. A cluster is a group of linked computers. Can't be one, it appears as one. The two most popular forms of building our clusters are failover clusters and load balancing clusters. And if you're going to create a load balancing cluster and you have the failover clustering feature installed, that needs to be removed first. You can do one or the other. Your network load balancing cluster can be built with as little as 2 servers, or as we call them, nodes, up to as many as 32. A failover cluster typically is used for back-end servers like a database or an email server. Network load balancing is used on the front end. It distributes traffic across multiple servers, in example, a web service. Each node, of course, just like in failover clustering, has to run its own copy of that desired service application. NLB can detect failure of cluster nodes, and it does that using heartbeats. And when a node drops 5 heartbeats in a row, that's once every second, so 5 seconds, it's then determined to be offline. We went through all the different ways to configure the cluster, work on port rules, what affinity is, the difference between multicast and unicast, and when you would want to use stop versus a drain stop action. And typically most of the time you're going to use drain stop. And then finally we discussed the two ways that you can upgrade a server 2012 or 2012 R2 server running NLB to server 2016. I hope you enjoyed this lesson. It's another portion in how we create network infrastructure that is resilient, can be scalable, and has high availability. As I say many times, I will see you in the next lesson or lab. Take care.